All right, we are ready to start topic 7. We're going to look at 7.1 and 7.2 today, and I think you guys are really going to like it. A lot of number sense and mental math opportunities for you, which I know is your favorite. So we are going to be looking at equivalent ratios and unit rates. So when we talk about a ratio, we just mean the relationship between two quantities. So if we say for every X units of one quantity, there are Y units of another, then X and Y are going to be called the terms of our ratio. So the terms of the ratio are just the numbers we're comparing. So that's the whole point of ratios, is to make comparisons. In an example like this, where we have 2 blue circles to 1 red square. So the ratio of the number of circles to the number of squares can be written in 3 different ways. We could use words and say 2 to 1. We could use a colon to separate the terms of the ratio, but we still read it the same way. We still read this 2 to 1. And we could also write it as a fraction, which is what we will do 99.9% of the time. And even though a fraction truly represents division, we could read this as a ratio still and say 2 to 1. So let's practice that. Take a second to write each ratio in 3 ways for letter A and letter B here using the colored pool balls. And I will work on that as you do as well, so you can check your work. So hopefully you found on part A that we have a 4 to 5 ratio, 4 solid balls to 5 striped balls. And on part B, we have 6 even numbered to 3 odd numbered. So when we get to a ratio like this, we can reduce these to lowest terms, which we will do in specific situations. So that is one of the ways that we will look at creating equivalent ratios. Because a ratio is a comparison of 2 numbers and can be written as a fraction, all of our fraction rules apply. So just in the same way, I could say 1 to 3, 1 blue circle to 3 squares. An equivalent representation would be 2 to 6, 2 circles to 6 red squares, or 4 to 12. And the way I get these equivalent ratios is by either multiplying or dividing by a factor of 1. So if I want to turn 1/3 into 2/6, I'm going to multiply by 1 by multiplying the numerator and denominator each by 2. And if I want to turn 2/6 into 4/12, I'm again going to multiply by 1 because multiplying by 1 doesn't change the value. And if I multiply my numerators, 2 times 2 is 4, and my denominators, 6 times 2 is 12. So I've created equivalent ratios. We can also use equivalent ratios to solve problems, such as this one, volunteering at an animal shelter. And we need to order supplies. We know that the ratio of kitten to adult cat supplies for each category is equivalent. Complete the table. So looking at my table, when I'm trying to order food bags, I need a different amount for kittens than I need for cats. And I don't know kittens. But if I look at my second row in the table, I do know both values here. So I can write my ratio of kitten to adult. So I will need 42 bags of kitten treats for every 56 bags of cat treats. And I'm going to use this to set up an equivalent ratio to help me figure out how many food bags to buy. So I don't know how many kitten, but I do know how many adult cat. So now I ask myself, how do I turn 56 into 8? So I'm going to need to divide here. Whatever I do in the bottom of my ratio, I have to also do on the top. So 42 divided by 7 is 6. So for every 6 kitten food bags I order, I need 8 adult cat bags. Now I'm going to use this ratio to help me determine how many adult cat food cans I need, because I know I need 126 kitten. Remember, kitten is the first term in our ratio, but I don't know how many adult cat food bags. So now I need to figure out, how do I turn a 6 into 126? Obviously, I'm getting bigger, so I know I'm multiplying. And if I multiply 6 times 21, that will give me 126 kitten food cans. So if I multiply by 21 on top, I need to also multiply by 21 on the bottom, which gives me 168. We're going to do a little more work with equivalent ratios, because equivalent ratios also helps us find unit rates. So if 3 teams train turtles for the 3rd annual Turtle Trot, which is a 30-foot race, we want to figure out, if they trot at their training pace, which turtle will win the race, by how many minutes, and we'll explain our answer. So let's check out the 3 teams. Our first turtle is going to be running at a rate of 18 feet per 6 minutes. Our second team turtle is going to be running at a rate of 12 feet per 4 minutes. And our third team is running 10 feet per 2 minutes. So we know from dealing with fractions that I can't very easily compare these because they have different denominators. But what I can do is turn them into a unit rate. So I want to know this turtle's speed per 1 minute, so that then I can compare them all. So I'm going to ask myself, how do I turn 6 into 1? I divide by 6, of course. Whatever I do to the bottom of a fraction or a ratio, I also do to the top. And 18 divided by 6 is 3. So this turtle is traveling 3 feet per minute. I'm going to do the same thing with turtle 2. I want to know his unit rate, how fast he's traveling per 1 minute. So to turn 4 into 1, I need to divide by 4. Whatever I do to the bottom, I have to also do to the top. 12 divided by 4 is 3. So again, we have another turtle traveling 3 feet per minute. And finally, I'm going to create a unit rate so I can compare all 3 turtles. And so I need to figure out how to turn 2 minutes into 1 minute. So of course I will divide by 2. Whatever I do on the bottom, I must also do on the top. 10 divided by 2 is 5. So this turtle is traveling 5 feet per 1 minute. So among our 3 teams, we have 2 teams traveling 3 feet per minute, and the third turtle is traveling 5 feet per minute. Since he is traveling more feet per minute, we would say that turtle 3 is going to win the race. But we need to know not only that he's going to win, but by how many minutes. So let's use equivalent ratios again to help us figure out how many minutes it's going to take. So if we're traveling, first team, at 3 feet per 1 minute, I want to know how long it's going to take him to complete the race, which is 30 feet. So I'm going to ask myself, how do I turn 3 into 30? 3 is 10 times as big as 30, so if I multiply by 10 on the top, I must also multiply by 10 on the bottom. So it's going to take this turtle 10 minutes to complete the race. The second team turtle is traveling at that same rate, so it is also going to take this turtle 10 minutes to complete the race. However, our winning turtle is traveling faster. So for this turtle, who's traveling 5 feet per minute to travel 30 feet, I need to decide, how do I turn 5 into 30? And of course, it's 6 times as big. So whatever I do to the top of my ratio, I have to also do to the bottom. And that lets me know that this turtle can travel 30 feet in 6 minutes. So this third turtle is going to win the race in 6 minutes, which is 4 minutes faster than the other 2 turtles. So he is going to win by 4 minutes. So let's dig into this idea of unit rates a little more, because a unit rate is going to be really important as we move into functions and graphs. So when we talk about a rate, remember we are just comparing quantities that are measured in different units, like we just did with the turtles, feet per minute. But when we talk about a unit rate, we are looking at the rate for 1 unit of a given quantity. So unit rate means per 1 unit, miles per 1 gallon, feet per 1 minute, dollars per 1 hour, something like that. So when we write a unit rate as a fraction, the denominator is always 1. That's how you know you have a unit rate. So when we read that unit rate, the 1 is read as the word per. And I'll show you what we mean, and it will make perfect sense. So if a car travels 120 miles on 4 gallons of gasoline, then we would say the rate is 120 miles per 4 gallons. But I know that 120 fourths can be reduced. I can write it in lowest terms, and in fact, I can write it as a unit rate with 1 as a denominator. So when I divide the numerator and the denominator both by 4, I get 30 miles per 1 gallon. So to read this rate, I would just say 30 miles per gallon. We don't even need to say the 1. And we can see from our diagram here that if our overall rate is 120 miles per 4 gallons, then that would be 30 miles per gallon. Just another way of representing that information with a picture. So let's check out our lobster friend. He is molting or shedding his shell 20 times over a period of 5 years. We want to know how many times per year he molts, so we're going to write it as a rate. 20 times, excuse me, for 5 years. If I want a unit rate, I want to know how often he molts per 1 year. I'm thinking, okay, to turn 5 years into 1 year, I need to divide by 5. Whatever I do on the bottom, I have to do on the top. So he is molting 4 times per 1 year. Easy enough. You probably did it in your head. Same thing here. The unit rate for 219 heartbeats in 3 minutes. Well, I want to know how many heartbeats in 1 minute. So of course, I need to divide by 3. Whatever I do to the bottom, I have to do to the top. So I know that 3 will go into 21 7 times, and 3 will go into 9 3 times. So that would be 73 heartbeats per minute. All right, so let's see how we can use unit prices, which is just a special form of a unit rate. So a unit price is a unit rate that gives the price of each item, or the price per item. So often you will find that buying things in bulk is cheaper. So if I'm buying movie tickets at a rate of $25 per 4 tickets, I can write it as a rate. As a unit price then, I can figure out by dividing the top and bottom by 4 that it would cost $6.25 per one ticket. So that